So today we're gonna move on to the third module, deep learning. And in its first lecture of the module, I'd like to talk about AI and its impact everywhere, including health. So that's the goal today. That's where we are. So again, we have already studied a classical problem and its classical approach. We have seen through these examples what optimization and machine learning problems are like. And we have seen already as well, even in the machine learning cases, what's optimization formulation and what's optimization algorithms. So now I think it's time to think again. At the very beginning, I suggested us to think from the data perspectives for this kind of problems, right? So we have protein sequence, structure, and other kind of data, like protein-protein interaction networks, protein expressions, and so on. And we have functions as well. So there are different kind of data of different modalities, and we're very interested in learning the distribution within each modality, as well as the relationships across modalities. So that's another perspective. So with this, we'll talk about deep learning more and more, including these contents. I actually have sent a short list of 8 papers covering CNN, RNN, language models, generative models, in the list, and I was asking for your preference, 1, 2, 3, so that we can find the optimal assignment of your journal club presentation. So we expect to start the journal club presentations after the spring break, which is next week. As a reminder, the homework 2 is due today, so if you need extension, please contact me early. And then we originally had the proposal due next Thursday, but it's a spring break, so we can extend it for 3 days, but not too much longer, to the Monday after next week, okay? We will also assign a homework 3 this week, which is very short. It probably only takes half an hour for some of you, but it could take an hour for some others. It's a machine learning programming homework. We can again set it to be due like the week after next week, like a late the week after next week. We'll decide. And then again, if you need extensions, but this one is even shorter than homework 2. Okay, so that would be all our homeworks. And I expect to return the graded homework 1 during or right after the spring break. Any questions about the logistics? Okay, please read the short list and cast your vote, 1, 2, 3, in that Excel sheet by the end of this week, before the spring break, okay? And as I said, I will solve a optimum assignment problem by formulating it into integer linear programming, very similar to the first problem in your homework 2, okay? I'm actually going to use the 1, 2, 3 matrix you give me and solve that integer linear programming and find the best assignment for the journal club, okay? Let's see how that works. When you give your 1, 2, 3, don't look at other columns. Let's make it as independent as possible, okay? All right, so again, these were already announced in the announcement last night. So, and after you're giving this preference, we'll give an assignment and give the date, okay? Please send me the slides no later than the noon on the day of the presentation, okay? Oh, actually, on the day before the presentation, by the noon before the day of presentation, okay? So, you can make updates between sending me and presenting the slides, but I'd like to load your slides at the beginning of the lectures to save time. It takes about 20 minutes, and we'll also ask people to have questions, so everybody is expected to ask questions, okay? All right, so what are we going to talk about? So today we're going to talk about AI. This is not a new word. It's an old word, well, relatively new. Well, we'll see when it was coined. But the concept is older than the name. We'll talk about its background and what it was meant for, and what are the recent breakthroughs. And then we'll see how the AI's impacts have outreached to many fields, including healthcare. Okay. And in the end, I want you to have this data view of our problems. There's artificial intelligence, there's biological intelligence at all scales. We're now just looking at molecules, but there are biological intelligence at all scales, okay? So toward AI, BI, that's my philosophy. And in the end, if time allows, we'll give a first take on neural networks, okay? So let's get started. So what is artificial intelligence? Before proceeding, what is artificial intelligence to you? It doesn't have to be an abstract concept. It could be a concrete example or anything. Can anyone? Actually, we only have a few people here, so I'm asking each of you give me one answer. Okay, so let me take a random order. Nami?
Any tool or machine that can do at the accuracy performance level of human beings.
So any what machine?
Any tool or machine.
Any tool or machine that can perform some task close to or at the same level of accuracy as humans. Is that right? Wow, okay. Okay, thank you. I mean, good. That's a good prior. Okay, great. Let's see. Heymin, what is AI to you?
I was thinking more in the line of any sort of algorithms that humans created that solves problems. So
Any kind of algorithms that human created and what?
old algorithms like vacuum tubes, like computers made out of those, could be considered artificial intelligence since they're artificial, like they're intelligence.
So you're saying that in not just algorithms, but also in the tools or physical systems that created.
It could be like too much broad of a view.
Right.
But in my sense.
So that's where artificial is from. But what about intelligence?
Well, them being able to calculate stuff.
Calculate stuff.
Uh-huh.
Good. Okay, you're all hitting something, some key elements. That's great. Okay, let's Do-Yang. What's AI to you?
Well, to me, any machine or tool that will make human give less effort to
Uh-huh.
get an output from some input.
Mm-hmm. Any machines that can liberate human labor and perform some task of getting some output from the input. Is that right? Yeah. Okay, great. Thank you all. And as I said, all of you have some key elements, and I really like it. So the background. As we know, AI is an old concept, a relatively new word. It's a coined word, born in 1950s, but the concept is earlier than 1950s, okay? We'll talk about how it's born as a word. And then AI is a very broad field. It includes a lot of research topics, and machine learning is just one of them. And it began to flourish from the 1980s, okay? Look, we built computers, way in 40s or 50s already, right? But the machine learning began to flourish in 1980s. And deep learning, as you know, is a subset of machine learning. It began to flourish thanks to the breakthrough of the CNN in ImageNet competition, right? We'll review that as well as when we talk about CNN. So in other words, AI includes machine learning, and machine learning includes deep learning. So it's an increasingly smaller and smaller subset. But now, as AI is getting more and more popular as a buzzword, very often when people are talking about AI, they are actually just talking about deep learning. Okay, so that's the situation. So so how was the field of AI was born, right? So let's look at this AI, right? So this artificial intelligence, as I mentioned earlier, it already exists to some extent before the word was created. Remember the first lecture we mentioned Norbert Wiener and the book called Cybernetics, the control and the communication in animals and in machines, right? So that, to some extent, is, related to artificial intelligence, right? Back then, remember, it was 1950s after the World War II. There are a lot of, automata theory and other kind of research already going. So it, as a concept, to some level, is already existing. Okay, we'll talk about Turing for sure, and then and again emphasize that. Okay, but how was this word created? So in 1950s, there was a very young assistant professor at Dartmouth College, John McCarthy, right? So he actually approached the Rockefeller Foundation and wanted to submit a proposal. Okay, back then he and Claude Shannon together talked with the director of biological and medical research at the Rockefeller Foundation, and they proposed the idea of having a brainstorming seminar at Dartmouth College in that summer of 1950s. Okay, and eventually it was meant for in a small group of 10 people. Eventually, a little bit above 10 people attended, and the proposal was by John McCarthy, and then, Claude Shannon, we all know, information theory, right? So, do you know Marvin Minsky? The founder of the AI lab at MIT, and what he's famous for? A lot of things. Among many, the first or the second winter of the AI was largely thanks to his breakthrough research. Okay, we'll talk more about it. And then Nathaniel Rochester. You don't know him or know about him, do you? The chief architect of the IBM 701. Okay, the first scientific computer. Okay, so these are the people who wrote this proposal. Okay, let's see what they were talking about. Okay, so the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. Okay, so that's assumption. Okay, so the every aspect of learning or the key feature of the intelligence can be in principle precisely described so that a machine can be made to simulate it. Okay, so something that you covered. So in other words, the field is about how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. Okay, so you all also covered something like this. Okay, And so, in other words, it actually covers all the remaining. Reasoning, problem solving, knowledge representation, planning, learning, natural language processing, perception, motion and manipulation, society intelligence, and general intelligence, and so on. So in other words, learning is part of it, and deep learning is a subset of machine learning, right? So now a lot of people are using the buzzword AI, but actually what they refer to is a subset of AI, which is deep learning, right? And back then, John McCarthy thought that he would like to create a new word, artificial intelligence, despite the other kind of related research, partly because he wanted to distance from those fields, right? Because those fields are already established with leaders, right? They have their own focus, and some of them are hard to argue with. So they thought, well, let's focus on what we want to understand, and create a new field and call it AI. So it's very important how you position yourself. Okay, so they made a right choice, but don't forget that at the beginning, these people, it's a dream team. Okay. All right, so that's the birth of the AI as a word. Okay. But as you know that AI research exists before the word was created, right? So one of the most famous scientists, and we're familiar with his name, is Alan Turing. Okay. So as you see, at the early days, you can wonder how human intelligence can be described and how machines can simulate. But how do you approach such questions is very important. Look, you can ask a very fundamental and important question, but more importantly, well, that's half of the success, but the remaining half of success is equally important, is how do you approach such questions? How do you plan milestones to approach that question step by step, right? You cannot ask a question that cannot be easily answered in the current technical world, right? So what Alan Turing's contribution is changing the question, very general question, can machines think? Okay, as I said, how do we precisely describe human intelligence and then let machines simulate it? So this question is unfortunately very hard to answer. And it's hard to, you would say yes or no or what. I mean, it's not very tangible. It doesn't really give you the right incentives in the specific research activities, right? It's hard to quantify, and it's really hard to even know what's the impact of the answer. Do you see what I mean? If I say yes, what do you do? If I say no, what do you do, right? So he actually smartly translated the question of can machines think to can machines do what we as thinking entities can do? Okay, so this is a very important turning point. Okay, it's a critical moment. That's the famous Turing test for machine intelligence. Okay, so when I heard Nami's answer, I thought, wow, that sounds like some element of Turing test, right? So I was happy about that. So here, what you have is like, you have a top view, right, of some cubicles, right? They cannot see each other, right? This is a top to bottom view. There is a computer or machine, and there is a human, right? They are both answering the same exam, okay? So how you design the exam is another question. And there is a proctor, right? The proctor cannot see who, he doesn't know whether the left cubicle is a computer or a right cubicle is a human or a computer. He just look at the two answers and then decide whether, he can differentiate the two based on their answers, right? So this is the Turing test, okay? If you think about this, as I said, it's a critical point of, making this study of artificial intelligence much more tangible and much more meaningful, okay? So as you will see later on, if you wonder why AI research turned out the way they were in 1980s or early 2000s, you will understand that it's Turing test, this philosophy of Turing test behind it, okay? So I will remind you that again. So let's talk about the AI and their recent breakthroughs, okay? I will talk the following. The first revolution is man versus machine, okay? So use games as test beds, okay? So you may wonder why we want to use game as test beds, because that's the perfect setting for Turing test, isn't it? Because you have the man versus machine on the same common platform, and these games at common platforms are already with established rules, right? Right? So you can unbiasedly just look at their performances and judge. So that's why in the early days, well, not so early, the recent AI revolution, they started with the games, okay? And then the next is the natural language processing. It's in the text and the speech data. And the next one is the computer vision. That's the image data, including how you analyze the image data and how you generate the image data. Okay, so, and there's more, okay? But let's focus on these three first. First, man versus machine, right? As I said, this is a perfect test bed for Turing test, okay? So the reason that early AI research, right, focus on the games, not for the sake of the games themselves. Of course, it gains popularity when you see that Deep Blue from IBM won the chess game, right, against a world champion, right? So maybe 2 out of 3 or something like that, but it was as early as 1997, okay? So still, after Deep Blue, people thought that, yes, that's amazing, but the complexity of a chess game is still, okay if you can consider some other games like Go, okay? This ancient Asian game, right? Whose complexity is much higher. I will tell you how much higher later. So people thought that, well, let's see. I mean, this is the beginning, but it will probably take another 20 years, okay, or 30 years, 20 years at least, to see a computer program beating a world Go champion, okay? We'll see how long it took. And also I want to remind you that this is not the first chess algorithm or a computer program, okay? Before that, I will show you the whole history. Before that, there were already a lot of other programs, okay? But this is the first time that we see it has reached the level of potentially matching or beating a human world champion. That's a quantum difference. So how long did it take from 1996 to 2015, right? So a little less than 20 years, right? So this is year 2015, AlphaGo versus the world champion Li, right? So if you play Go or you follow the Go news, you would know that back then he was the Michael Jordan of basketball, right? And I want to remind you that the complexity of Go is a Google terms more than that of chess. It's not my typo, it's Google, okay? What's the magnitude, order of magnitude for Google? 10 to what? Want to guess? You want to guess? 10 to 1? 10 to 10? 10 to 100. So the complexity of Go is 10 to 100 than that of chess. So people thought that this day will become a little, will come eventually, but it's going to come a little later, okay? And this was the game, right? But as I said, that back then AlphaGo, right? So it was based on the Monte Carlo tree search, right? And it was trained on data created by human, right? So so that was trained on data created by humans playing humans, right? And then they further evolved, right? So they basically now they train over time using large quantities of human knowledge and supervision. A new system taught itself to master the program. So it's like a baby learning the new knowledge, right? So it knows that in this world, right, what is the rule? So it keeps trying to play the game, right? And then gradually grasp and reinforce the knowledge. And then you see that it eventually start from the naive player, and then it actually can learn, right? It can learn from playing with itself, and then gradually improve in 40 days. So that's another level of AlphaGo called AlphaGo 0. Okay, and again, this was just the epitome of man versus machine in games, because as I said, it's a perfect test bed for Turing test. So there are all kinds of AI products ever since the 1950s. Okay, so in 1956, IBM Checkers AI first demonstrated. So that was 1950s. Okay, so I know IBM may not be the first name you think of right now when you think of AI, but in more than 5 or 6 decades, IBM has been leading the AI revolution, among others. Okay, the first chess AI, right, fully functional, was in 1958, right? And the Checkers AI actually wins in 1962. Those were the checkers, right, relatively simple, right? And the first world computer chess champion, back then they already have the computer chess champion. That was in 1974, Kaisa, right? So the CNN as a concept was introduced in 1989 and backpropagation in 1989, 86, right? So we'll talk about them when we talk about deep learning. In the meantime, we see technology-wise reinforcement learning and neural network-based backgammon AI, as research has been shown in 1990s, early 1990s, right? So the Monte Carlo goal was in 1993, and the Monte Carlo tree search goal in 2006, okay? And then got improved by DeepMind's AlphaGo and AlphaGo 0, right? So this Monte Carlo tree search based Go actually, already started in 2006, okay? But it still took some years until it actually reaches some level and eventually beat a human world champion, right? That took more than 10 years from 2006, okay? So there's a whole history behind it. If you are interested, you can look at this blog, okay, or editorial. So after man versus machine, let's talk about natural language processing. Okay, so it's actually so popular right now, but first I still want to bring back IBM. Okay, so in 2011, right, you must have heard of this. 2007, 11, sorry, that's 11 years ago. How old were you? You were middle school students, right? Did you hear about IBM Watson wins this game called Jeopardy? Right, you must have heard about something like that. And that was in 2011. So in this kind of game, you have to process the natural languages. Okay, so it's one of the early breakthroughs. And then, ever since then, natural language processing has been seen in so many applications. For instance, virtual assistants, right? So the first chatbot actually was already invented in 1966, okay? But now I think it's much easier and natural for you to talk with a chatbot, right? Like if you're talking with GPT, right, version 3, right, maybe it feels so, you can do your own Turing test, okay? Then, for instance, there are a lot of email assistants, right? When you send an email, you CC those email addresses, and those are actually, email assistants that can directly, based on the content of your email, assign this task into your Google Task, or put this on your Google Calendar, or send this to your Slack bots, right? So it's like a virtual assistant, exactly like someone it's like you hire a secretary, right? And these processing of natural languages don't have to just go through the form of text. It can go through the voices, right? So in 2011, Siri was born, right? That was Facebook, and then Cortana, right? So that's Microsoft 2014. Alexa, Amazon, right? 2014. Google Assistant to 2016. Actually, Google Now was even earlier, 2012. Okay, so this natural language processing is now in our day life, right? You can talk to Alexa, right, and play this music, order that thing, right? Another thing you may realize is that now a lot of the translations are getting more and more real-time and precise. That's also largely thanks to natural language processing. Okay, it's not only about processing the information from the text and the voice and do actions. It's also about translating across different languages. Okay, so Google's neural machine translation was in 2016. Okay, I want to remind you that the early days of Google's translation was not based on, that was not really that much based on what you imagined. Okay, at the early days it was actually more based on the search. Okay, but now it's really building in more intelligence into it. And now you probably sometimes even get annoyed that when you are typing your email or your text message, sometimes it auto-fills or complete the sentence for you, right? And sometimes it could be a huge mistake or joke sometimes, right? So the last revolution after games and natural language processing is in image data, okay? The image data, again, is getting more and more widely accessible, right? Thanks to the digital cameras, right? And the storage, so as data get, as data get more and more abundant, then these technological improvement get more possible, okay? So the data storage, retrieval, all this, data creation, collection, storage, retrieval, and corresponding hardware, once these are mature enough, then the software level artificial intelligence improvement or advancement become possible, right? So I have to talk about ImageNet, right? So as I said, for AI, you are asking about the question whether the human intelligence can be precisely described in a way that a computer can simulate it, right? And you know that this problem is much more approachable using the Turing test. In some cases, like games, that Turing test platform is very readily available. That's why early AI research was so focused, not so focused, but was massively using games as a test bed, right? But in some other cases, like this, for instance, this image tasks, right? If you want to tell or annotate an object, right, on this image, or you want to segment the image, like annotate which pixels or which blocks of the images corresponds to the crosswalks or the traffic lights, right? So that kind of thing is, again, at the beginning is limited by the data and the rules, especially the rules. In other words, the label. There's not a lot of labeled data, okay? So maybe after you get a lot of data after the collection and the storage and retrieval hardware, but now you're missing the labeled data, okay? So that's why Fei-Fei Li started this ImageNet, right, which is a great initiative, right? So it's about the platform that makes the visual intelligence possible, okay? It's like that Turing test bed, okay? So this makes it possible, and now actually, this labeling efforts are largely accelerated, right? Thanks to what? The crowd wisdom, right? Amazon Turk, right? You can hire people, right, with relatively cheap budget, so that they can just label images for you, and then sometimes even for free. Right? You must have done it before. Have you heard of CAPTCHA? Have you heard of reCAPTCHA? Sometimes you are suspected that you're a robot, then it asks you, please label all the images that has a bike or pedestrian, right? So as you were testing yourself to be a human, you were also donating your labeling efforts, right, to this database, whether you realize it or not, right? So anyway, ImageNet then grows into a competition, right? So any field, if it wants to advance, it needs standardized and abundant data and assessment. Okay, so ImageNet is making that possible. And then over years, people use ImageNet as a test bed for visual intelligence and testing their algorithms, and they have a lump sum performance metric, which is the slower the better, right? And the average human can reach 5.1, okay? But over the years, they see the scores gradually decreasing, but looks like it's saturating, right? And, but then one year, that is 2012, okay? So before 2012, people see that these methods are getting more and more sophisticated, focusing on a lot of human manual and feature tuning and all other kind of things. And all of a sudden in 2012, these performance metrics drastically improved. And people were asking, what just happened? So this is ImageNet in 2012. And 8 years later, the same thing happened in protein structure prediction. So there is a platform called CASP, Critical Assessment of Structure Prediction, right? So it's been probably as old as you, like 20 years as a concept. And in practice, maybe 16 years, 15, 16. That's the same thing in that year, 2020. People wonder what happened. Actually, even before the CASP competition was finished, during the competition, because of the targets, the protein structure prediction targets, were gradually rolled out. So the organizers and assessors can already see the performance of the earlier submissions. They already noticed that there was one team that keeps submitting high quality predictions that just way outperforms others. They were even wondering, is this guy cheating? So that was what we later know as AlphaFold 2. Okay, so that's what I call it the ImageNet 2012 moment of CASP, or protein structure prediction. But back then, that year, what happened was AlexNet. Okay, so when we talk about convolutional neural networks, we can talk a little bit about AlexNet, but basically that's the beginning of, what should I say, these AI waves. Okay, before that, I don't think it's a highly recommended topic for graduate students if they are concerned about their jobs. Okay, but now it's probably a different story. Let's see. After that, we see deep learning is improving, right? So all kinds of architectures, and some of them will be mentioned when we talk about convolutional neural networks, and then you see that it's even reaching or beating human levels. Okay, so that's just crazy, right? But this is just analyzing images, okay? What about others? So if I let you see, these nice pictures, of beautiful human beings, right? Where living in this beautiful world surrounded by beautiful people, not just beautiful for their faces, but their hearts and their actions toward each other. So I wasn't actually very afraid to show these people's pictures and worry about the intellectual property. Okay, I know there are some databases that give this royal-free use of images. You can use them without worrying about the intellectual properties. But here, I don't worry about it at all, okay? And I will tell you why. In the meantime, if you're on LinkedIn or Instagram and one of this profile wants to connect with you, would you think twice? You would? Why? I don't see anything evil from them. Why?
Probably a fake.
What do you mean? So, so this word, fake, entered our life 6 or 7 years ago. There is some, there's a parallel, right? One is a fake word that kept being used by a president. So in the daily life, you hear about this fake and the fake. So all of a sudden in our daily world, the use of fake just increased so much, right? Then there is a tech world. This word fake also got much more usage thanks to a technology, right? So all these pictures are taken from thispersondoesnotexist.com, okay? Actually, just as the name suggests, right? So none of them exist. So these images are created or synthesized, okay? Actually, there is a new website called thismoleculedoesnotexist.com as well, if you're interested in, okay? So, if you watch this video, and you will see, this is basically, again, let me abuse the word fake. It looks like Obama talking about something, but Obama never made that video and never talked about whatever is taught. And it was created by the Deepfake, okay? And the technology behind it is GAN, okay? I wonder why, well, this name is really, is really easy to understand, right? But I wonder if we lived in a different era with a different president, would we still call them Deepfake or something else? But now everybody is using that word so liberally, and deepfake is affecting our life. Okay, so you got to be careful. In the past, when you go to a court and you say that, well, that image is not mine. He photoshopped. So now you will go there and say, oh, it's a deepfake. so you don't know what to trust now, right? So this is the image creation, okay? But there are way more things than that, right? So as we see that, other things may be harder to lump into one domain, but there, we see unsupervised, self-supervised learning, reinforcement learning, neuroscience inspired AI, and so on, right? And I posted today that if I look at what DeepMind has contributed in the past, so many breakthroughs, but I can see 3 of their first milestones in each of the following field. The first is AI in games. That is 2016, AlphaGo, right? The second one is AI in science. That was 2020, AlphaFold. And the third one is actually today. Okay, this is AI in humanity. So if you check the latest Nature journal, the feature article is called Ithaka. Okay, Ithaka is a computer program that helps archaeologists recover the inscriptions on the ancient Greek, stones, right? Those stones. If you are familiar, for instance, the Rosetta Stone is a very important and famous stone, right? If you went to the British Museum, it's out there, right? So it has 3 different languages describing the same thing, and that was a key for translating some old languages, right? So there's still a product called the Rosetta Stone for you to learn languages, right? So Ithaka is again named after ancient Greek, and so I'm really excited at what AI is creating, but we also have to be aware of what it's negatively impacting us. Okay, we will talk about AI and whether AI products are contributing to or sometimes damaging fairness, right? For instance, right, or equality, or all of that, right? So we have seen controversial incidents where AI products just showed a lot of biases in their judgment, but maybe those biases are eventually in the human, right? In the data that's used to train the AI products, but eventually came from human. And there are a lot of pitfalls for us to address, okay? But overall, I think this is just another beginning of great things, and we are all fortunate to live in this era, okay?